Before we start working on integrating a controller into our portable, let's have a look at one last finished project. Here is ShockSlayer's Wii laptop, the ZNWii 2.0. He has been one of the most active portabilizers out there and a great source of inspiration. Could you tell us how this project was built?
Sure. Well, with the ZNWii 2.0, the top and bottom halves are both, stock cases that I ordered online from Polycase. And then, of course, after looking at those, I drew up the designs and did all the measurements. And then I had a friend put them together in a CAD program. And then when we sent these off to another friend, and then he used his CNC machine to cut everything for me. So, I love the pre-made cases because they're super strong. And then when you CNC them, there's like virtually no weak points. Because, if you were to Frankencase something, you'd be putting in plastic and then you'd be epoxying in that. And even if it's sanded perfect, it's still basically a weak point. So, this is important to me in commissions because I can create a solid product and not have to worry about the case cracking or breaking like years down the road.
Can you describe the parts inside?
Let's look at the top half. If you look straight at it, you see, okay, it's got the screen and it's got the speakers and the volume control. And then, of course, you have the sensor bar in there. Like anyone that has a Wii is familiar with why you need that. And then I think the low battery indicator is up there. Because, that's what you're going to be looking at. So when the battery goes low, that's, where you need to see it. So, and I think in the bottom half of the case, it's pretty much everything else. That's where the Wii is and the batteries and the heatsink, the fan, power switch, etc. All the miscellaneous stuff.
How did you manage the cooling of this system?
With the ZNWii, the first unit that I made had the heatsink flattened down, and I used a different fan. But when I designed this unit, I wanted to keep the stock heatsink and fan, and then have two incredibly large vents cut on the top, so there was plenty of airflow. And I had to rearrange how I did everything on the inside to make sure that I had room for that. And then after stress testing and running the unit for hours on end, I didn't have any heat issues at all, and the unit was still cool to the touch. So that's a win in my book.
What makes this portable special to you?
What really makes the portable, what I like about it the most is, the first one that I made was designed to be incredibly solely portable, and so I skipped out on some of the extra ports and flattened everything out and made it slim and built it in a couple days. But with this one, I completely redesigned it based on everything that I learned from the first one. So I relocated all the ports, made sure to include all of them, the cooling's better, and it takes SD cards this time instead of the internal hard drive. So, and Wii laptops aren't that common of a project. There haven't been that many of them, and I'm pretty sure that this is the first fully portable one that has all of the features of it. So I'm pretty proud of that.
Once again, big thanks to ShockSlayer for showing us his project. For more videos and tutorials, visit his YouTube channel. Let's start by opening up the controller. For now, just keep everything except for the rumble motors. If we look at the case we made last time, it seems obvious we can't seamlessly integrate a controller's circuit board. So, we're going to need to extend the buttons on that circuit. Luckily, controllers are quite simple. There's no need to understand how they really function. Let's leave the chip alone and not touch its surroundings. It's too complicated. Then, what we're left with are essentially wires going to buttons. To make things clear, let's review what a button or a switch actually is. It's just an open wire. When you close it, the chip detects it. So, theoretically, this open wire can be elongated or replaced with any similar contraption. To illustrate that, here are a variety of switches connected to the A button. The original A button, an on-off switch, two types of tactile switches, and an actual open wire. Now that we know this works, let's cut up the circuit to gain some space. As we just said, the chip is left alone, and everything is rewired around it. The circuit board is cut with a Dremel, but it can be done with a saw or scissors. After cutting a circuit, it's better to sand its raw edges slightly to ensure no copper dust can short the circuit. Now's the time to solder each button. They can be directly connected to the chip, since the traces lead directly to it. Some areas you can't solder directly, for instance, where there is paint on the copper. just scrape the traces to reveal the copper and try not to damage it. You'll need to figure out what wire corresponds to what pin. For that, just use a multimeter. As usual, check each connection and seal everything in epoxy. That way, the wires won't short. When all that is done, let's add some tacked switches for Z and start. As for the triggers, they will be replaced by 2 tacked switches each. It's a good way to save some space. And there we go, we have successfully cut apart the controller and kept it fully functional. Next time, we're gonna have to modify the case to access the buttons and actually play. If you enjoyed this video, please like and subscribe. Check the video description for music links.